started section 1.1, equations last time, and we had done two types of equations, linear and absolute value, and we left off at the very end with rational equations. All right, so we talked about linear equations where we had numbers in the denominator before. And when we did that in intermediate, we tried to clear out the denominator, right? Our goal was always to clear out the denominator. In fact, we did one in here last time as well. Problem number 3, where again, we found the least common denominator of the denominators, right? And then we multiplied by it to clear out all my denominators. So I can do the same thing even when it has variables. So to start with, in order to make this work, we've got to be able to factor anything that's factorable. So the first one, x minus 1, that's done. I mean, there's nothing to factor. X plus 1, nothing to factor. But x squared minus 1, there's something to factor. And it looks like something we have seen before. Do you remember how x squared minus 1 factors? Yeah, it's a difference of squares. It's x plus 1, x minus 1. And you'll notice that looks like the other denominators that are already there, right? So that kind of shouldn't come as a surprise. They're going to be familiar pieces that are already present. They're not going to have 3 completely different denominators that have nothing in common. That's not the way it's going to work out. So I'm going to make this a little bit smaller as a reference point now that I've drawn it big enough. So my common denominator is going to have an x plus 1 and an x minus 1. Does that make sense? Awesome. So what that means I'm going to do is I'm going to multiply each fraction by x plus 1, x minus 1. Now, I know it's kind of a mess, but the reality is that the whole purpose in doing so is that some of them are going to cancel. So the first denominator is x minus 1. It will cancel with the x minus 1 I'm multiplying with. Now, I'm not going to go ahead and do it right now, but I'm going to have a 4. Oh, I need to white. I'm going to have the 4, and I'm still going to have the x plus 1. So I will have to distribute that through in a moment. That's the pieces that didn't cancel. On the next one, the x plus 1 denominator cancels with the x plus 1 that I'm multiplying by. So I have the negative 9 still left, and I have the x minus 1 still left. And then on the last piece, the x plus 1 cancels, the x minus 1 cancels. So that eliminated the whole denominator, which was what I factored, right? And all I have left from the numerator is simply just a 3. Okay, so the reason these 3 types of problems are in this particular section is because once I do some sort of a cleanup step, they become linear. Okay? I don't have any x squareds in this anymore. They eliminated. The same thing happened with the absolute values when we did them last time, right? Once I separated the absolute value out into 2 pieces, right? That wasn't it, it was this one, right? Separated out into 2 pieces, I just had linear equations and all the same techniques that we had applied. So there's sort of this front end work involved, but the ending part matches what we already know how to do. So we're going to distribute the 4 through. So I have 4x plus 1, right? And then I'm going to distribute my negative 9 through. So I have negative 9x. Oops, I'm so sorry. You're right. I miswrote that down. Thank you so much. 4x plus 4. Distribute my negative 9 through, so negative 9x, and then negative 9 plus times positive 1 would be a positive 9 equals 3. Okay, so we'll simplify everything on the left-hand side by combining the terms that are alike. So I have 4x and negative 9x, which is close, it's negative 5x, yeah. And then I have 4 and I have 9, which gives me 13. Still equals 3. We'll subtract our 13. So now I have negative 5x equals what? Negative 10. Yep, keep the sign negative. And then if I divide by negative 5, yep, x equals positive 2. Now, you have to be careful when you're working with rational equations, just like you have to be careful a little bit over here with the absolute values, that the value actually made sense back in the original problem. We tested each of these to make sure, I think we did, or at least we talked about them, about whether they made sense in the original problem when we got our answer. So over here, the same thing is true, x equals 2. Now what we really need to be concerned with is not necessarily plugging it in everywhere and making it work. What we really want to be careful about is that it doesn't end up making some denominator somewhere equal to 0, because that's what could happen because of the way we did the problem, is it could end up giving us a value that actually makes the denominator 0. But 2 doesn't do that here, right? Now if I'd gotten an answer at the end at x equal 1, that'd be a problem, because that would make at least 2 of my denominators equal to 0. So let's say, for instance, we did get a value at the end. We only got one value, and that value, we look back at the original equation, made the denominator equal to 0. What would the answer then be? Nope. Yeah, it'd be no solution. Yeah, we did that marking last time with the 0 at that slash through it, right? It would be no solution. So if I got an answer at the end, right, if this 2 at the end actually made the denominators at the beginning equal to 0, it wouldn't be a solution. It would be no solution because it didn't work. Okay? So this one does work. There's no problem with this one, so x equals 2 is my solution. Okay, let's try number 10, our last one. Okay, so again, 2 of my denominators are already simplified. There's nothing to clean up or to factor. But the third denominator, I do need to factor. How will x squared minus 4 factor? X minus 2, x plus 2? Sounds good. Everybody okay with that step? Okay. So you notice that that means my denominator now has an x plus 2 and an x minus 2, right? Those are the pieces that I need. Agreed? Okay, so I'm going to actually multiply by both of those pieces every single one of my 3 fractions. So x plus 2, x minus 2. X plus 2, x minus 2. And x plus 2, x minus 2. Now, I don't want to distribute out x plus 2, x minus 2. I don't need to do that. The whole reason I chose those is because they're going to cancel with pieces, right? So don't get carried away and try to multiply things through. That's not really what we want. We really want canceling to happen. So this x minus 2 will cancel with its x minus 2 on the first fraction. The x plus 2 will cancel with the x plus 2 on the second fraction. And the x minus 2 and x plus 2 will cancel with them on the third. So back at the beginning, the 3 remains, as does an x plus 2. In the middle, a 4 remains, as does the x minus 2. And at the end, it's 7x minus 2. Okay, so far so good? All right, we're going to distribute through now, right? So I have 3x plus 6 plus 4x minus 8. The right-hand side stays the same. And we'll combine like terms. How many x's do I have on the left? 7x. And how many constants do I have? Negative 2 or minus 2, either way. And what do you notice at this point? They're absolutely exactly the same on both sides. We saw that happen last time. What does it mean?
Infinite solutions?
It means there's infinitely many solutions. That's true.
So how do you write that without having to write all of it out?
Well, what's happening here is that we have an identity, by the way. Also, we talked about that word last time. You really can't. You just have to write down there's infinitely many solutions. Now, there is one other way, since we just have x's involved. You could say x is a real number. That's another option. X is anything. Okay? It has to be a real number. We're only working in the real number system right now, so.
Did we say it was an identity, or do you want us to put
The question will be specific. You won't have to worry about what it's asking. It will specifically say, if it's an identity, say it, because you're working inside of a system that has to tell you exactly what it wants.
Okay.
Yeah, so it'll be really clear. Okay, any questions on that? All right.